Hi, I'm Sean from Star Labs, and we're making this video to show you all the options we have in our coreboot firmware, as there's quite a lot of them. Some of them are straightforward, like turning off the wireless, and then some of them are more complex, like setting power limits and things like ASPM, which are power saving features. So to access the firmware settings, you have to do it from a powered off state. When you turn it on, it starts up, and then it will display a prompt on the screen telling you what keys to press. In our latest releases, you can press F2 or down. So when you see the text in the top left corner, you press the down key and it will load up the settings. In here you've got relatively normal firmware settings like a boot menu and a boot manager. So if you want to boot from a USB or change the order of things, they're in there. They're relatively normal compared to closed source firmwares. In here you have the vast list of things that we've added to coreboot over the years. So I'll run through them relatively quickly to give you an idea of what they do. The first one is the boot timeout. So when that text shows up on the screen, it's actually slowing down how long it's taking to boot. So the default is 3, so it will be 3 seconds that you can press that button. You can change that down to 0, so it will actually boot instantly, or change it up to 10 seconds, however it suits you. Then in the audio section, you have the digital signal processor, which basically tidies up the audio signals. So that's for speaker output and microphone input. This is something that only works reliably on Linux. So if you're using Windows, then you should switch it off. For the normal, enable disabled, you simply press enter and it will change from enabled to disabled. Legacy speaker control is specifically for the 𝗏𝗏𝗁𝗏. Older kernels struggled to turn on the amp without making a pop sound. So this is on by default and that will avoid the pop sound. If you're in a newer kernel like 6.19, then you can change that to disabled and it saves a very small amount of power, but that option is there. Then the next section is battery, so charging speed. Your options here are 1C, 0.5C and 0.2C. What C stands for is the size of the battery. So in the 𝗏𝗏𝗁𝗏 here you have an 80 watt-hour battery. If you set it to 1C, it will charge 80 watt-hours maximum. This is still interpolated against temperature, so if the battery gets too hot, it won't force charging it and wreck the battery. But essentially the general rule here is a faster rate will charge the battery quicker, but it will wear it out more. So the ideal is to set this to as low as possible that you can tolerate. If you set it to 0.2C on a 𝗏𝗏𝗁𝗏, it will take about 10 hours to charge whilst you're using it, but that will make the battery literally last sort of 8 years. Not many people can tolerate it charging that slowly, so it's entirely up to you. The next one is the maximum charge level, so the level that it will charge up to when it's connected to power. The default was 100%. You can change this to 80 or 60%, and again this extends the life of the battery. So what it will do, if you set it to 80%, it will charge up to 80%, and then it'll let the battery run down to 75% and then start charging again. And that short discharge cycle is the best way to keep the battery healthy for longer. So the next one is power on after failure. So in the laptop, if the battery runs flat, that's a power failure. Or if you've got a mini PC and you have a power cut, that'd be a power failure. Setting this to enabled, as soon as you get some power again, it will turn automatically. Some people find that quite handy for the mini PCs when you have a power cut and you want it to turn back on automatically. The next one is the debug level of the console. Very few people want to look inside the debug logs of coreboot, but if you want to, you can get it to be different levels of talkative. Generally speaking, the debug level is what most people use. So then the next one down, you've got card reader. So this will be available in all of our models that have a card reader, but you can disable it just if you don't use it, just to save a small amount of power. The same goes for Thunderbolt. Thunderbolt ports, even when they're not being used, use a small amount of power. So if you don't have any Thunderbolt devices, switch it off and you'll save a bit of power. The next one is function control reverse. So this was added on request from a lot of people who are coming from MacBooks, where Apple decided that function should be first before control. So you can enable that and it'll essentially swap the keys around and make it more like an Apple keyboard. Keyboard backlight timeout. So every time you press a key, it will turn on the keyboard backlight, and then the default is 30 seconds. So after 30 seconds, it will turn off the backlight, and that's the way to save power. So you can set it to different timeouts, stay on for 5 minutes, or just to stay on continuously. You can also adjust the backlight intensity with the F11 key, so you can change that from off, low and high. It will remember that setting between reboots, so if you never want it on, turn it off and you'll never have to think about it again. The trackpad section is specific to the fighter because it has a haptic trackpad. You can change how much it vibrates. Some people like it to have a lot of feedback, some people like it to have none. It really is whatever floats your boat. The click force and the release force is how much you have to press it for it to do a click, and then when you take your finger off, how much you take your finger off for it to do a release click. The defaults are what most people like, but some people like tuning this. And then the tracking speed, this is how fast the trackpad will monitor inputs. Balanced is generally sufficient for most people, but if you're someone who does like a lot of clicking, then you can dial this up and get a ludicrous level of precision from it. It does use a marginal small amount of power extra turning it up, so it's one to experiment with, see if you have any advantages with. LEDs, by default, they run at maximum brightness. This is something that people like changing on the Starlight particularly, but you can either set the charging and power LED to be normal, low brightness, or off. Again, that's personal preference. Power management for PCI devices. So in here, these are dialed up to the maximum power saving. So your wireless and SSD will save as much power as they can. Clock power management one is that you should leave on generally all the time. There isn't really any advantage to turning it off. ASPM and L1 substates, for most people, leave them on. There are marginal performance gains if you set them to disabled, but they do increase power consumption. Some older Linux kernels do struggle with ASPM set to having L1s enabled. So dropping this down to L0S if you're using something very old can help. Next, you go on to the performance section. I'll just knock that down so it's easier to see. Fan profiles. So you can either disable the fan. You can do this on all of our computers that have a fan. So it's normal, quiet, or aggressive, just depending on sort of noise tolerance to performance preference. Obviously, if you do set the fan lower and it gets hot, it will limit your performance, so it doesn't get too hot. Normal is what most people end up using, but if you're a power user, aggressive does bring the temperatures down quite well. Hyperthreading is an Intel specific thing where you can run two things in one thread. This is one that people aren't decided on whether it's best to have it enabled or not. So entirely up to you there. Memory speed. This is only available on our computers which have onboard RAM, and you can basically dial the memory up or down. Lower is generally more stable, and faster is higher performance and uses more power. The middle ground is where most people end up, hence it's by the default, but it's a personal preference one again. And then power profile is literally how much power the CPU can use and when it will start throttling depending on temperatures. So you've got three basic profiles in there: power saver, balanced, and performance. They're relatively self-explanatory, but if you want to customize it more, you can change it to custom. And then in here you get PL1, PL2, PL4, and TCC. So PL1 is the amount of power the processor can use all of the time. So the Starfighter, the default, it can use 45 watts of power continuously. PL2 is the sustained boost, so it can jump up to 80 watts if there's some intensive task to do. And then PL4 is the hard limit, the max amount of power it can use. So you can literally change these values to what you like. There are limits in there, so you can't do anything insane or that will damage the hardware, but you can tweak this to your heart's content. And then the TCC, this is the temperature in degrees of when it will start to throttle the processor to stop it getting too hot. So if you feel it's too hot or you want to get more performance out of it, you can change that, say, to 90 degrees. And then as soon as the processor reaches 90 degrees, it'll dial back performance to stop it going after that. VPU is a PCI device that's often used by LLMs to enhance performance. not many people seem to be using LLMs locally, hence why it's disabled by default, but if you want that, you can just turn it on. Next, you jump on to the security section. BIOS lock essentially locks the SPI flash, which is where the BIOS lives. If it's disabled, then say you're running Linux, anything with root privileges can write to the BIOS. So write coreboot if you built your own version, or even something technically malicious can write to it. So in theory, you leave this on. The LVFS delivers updates via capsule, so they're all signed, and it will install with even this being enabled. The next one is total memory encryption. This encrypts the contents of your memory whilst it's running. Security feature, there is a very, very marginal performance penalty for having this enabled, but if you're traveling around with your device, the merits are usually self-explanatory. You can disable this if performance is the priority. Intel Management Engine, most of our customers will know of. You can enable or disable this, and this is quite a big topic, so we've got a support guide on our website if you want to read more about the Intel ME. So the next one is BIOS password. So you can essentially set a password to lock access to this screen. So if you set that, every time you try and enter it, you have to enter the password. That can stop people changing boot orders or booting from USB drives, that type of thing. The next one in the menu is Secure Boot. So Secure Boot is a standard from the UEFI organization. It can help prevent booting malicious operating systems. Not all Linux distributions support this, which is why it's disabled by default. But if yours does, you can enable it, and generally speaking, there aren't any negatives to it. There are different opinions out there, so it is preference. TCG disk encryption, so this is the Opal standard. So we now use Samsung 990 SSDs for all of our laptops at the moment, and they support hardware encryption. So you can set a password here. So every time you turn on the computer, you have to enter the password for it to unlock the disk. Without that password being entered, you can't access any of the data in the disk. So it prevents anyone from taking your laptop and even booting it for starters, but also taking the SSD out and putting it in another computer because that password is still needed. The caveat is if you ever want to transfer that SSD to another computer, you need firmware that supports TCG disk encryption, and it's not that common of a feature. So just be aware of that. Next one is the TPM, which is a security chip. Again, quite extensive topic. There isn't much in terms of configuring it, but you can store keys in it. So the option in the firmware is just to clear those keys out if you ever need to. The next one on the list is the lid switch. So by default, when you close the lid, they will suspend. You can change this so it'll only sleep when you close the lid, but you can open the lid without it waking up, or you can be completely ignored. This is something that people have asked us over the years. The next one is virtualization. So if we're running virtual machines and things like that, you can turn that on or off. There are some security concerns about virtualization, hence why it's enabled in there. And then the final menu is wireless. So you can turn off Bluetooth and wireless. So if you turn off Bluetooth, the OS can't turn it on no matter how hard it tries. The firmware will disable the RF and the device itself. This runs in tandem to our kill switches. So say for example you never wanted to use Bluetooth, you can set that to disabled, leave Wi-Fi enabled, and then say you boot Ubuntu, you'll have access to Wi-Fi there, hit the kill switch, and that will just turn off Wi-Fi. The other setting in there is Bluetooth runtime D3. This is a relatively new feature that Linux uses and essentially saves power for Bluetooth when it's idle. It's disabled by default because not many distributions support it, and Windows can't handle it in the slightest, but it's worth trying to see if it has any ill effects on your distribution, because it does save a fair amount of power for something that's generally not in use all the time. And that is the full list of our options. Thank you for watching. We've got a few more videos planned on different firmware related topics. So if there's anything you want to see or anything else you want to see in coreboot, then do let us know what you want to see.